now that we have these things about the orders at which the arguments are passed, but here we don't have, um, we kind of have the same problems as before. Uh, if we type in these functions, we're not as much flexible as we want it to be. Because if you change the order of the function, the arguments, or you change the number of arguments, the call to this function won't work. For example, you cannot call this function with, for example, 2 arguments, because we hard coded the call, the call to the var function. We can only here, we can only call var twice. The first call will be a string and the second call will be an integer, but these calls won't work because only 2 arguments has been passed. Now, what if we want to make these things work? So we have to find a way to let the var arg, the print function, to understand that the argument that we have passed are of a certain type. How do we do that? The first thing, we have to be we have to agree on a convention. Let's say we're going to say if 1 will represent a string and 2 will represent, for example, an integer, and 3 will represent a number or a character. And what else? We can say that 4 will represent a floating number or a decimal number. Now we can pass this information to the printf function in the following ways. Let's say we're going to pass as first arguments, we're going to pass in a strings instead of the numbers of arguments. So the first argument, since it is a string, so since we agree on that 1 represent a string, so we say this is 1, and the second argument is an integer, so we say 2. Now back in the print function, the parameter we receive here is not the count of arguments, but it's now a string. We can loop over strings and read the characters and understand and determine what types are the next arguments. So the var start will receive the s as the variable, the parameter s as second parameter. And let's delete this. So let's loop over the string that we received. So we say for I, we know that a string ends with a null character. So the I start at 0, while as the character as at position I is different than the null character. we move forward to the next character. And here we have to do some checks. We check if the current character, if SI or the current character is equal to 1, to the character 1, that means we are reading a string. So we call the var as the following. So var is, if we read it with the type ***. So we know that if we encounter the character 1, then that means we should call var with the string type. Else, if the character is a 2, that means we are reading an integer. So the call to var is going to change. So var list, and we have to specify the type int. And next, we said that if the character is 3, that means we are the next character we are reading is a character. So we call the function like that, var list. For the characters types, we still need to pass in ints to var. We could have passed in char, but the var is expecting the ints for integer types and characters. Now the next one is for the decimals. If the character we are reading is 4, then that means we are reading a floating point number. So we're going to display the floating point number, and we call var with the type double. Now the function is now a bit more flexible, because based on the character we are reading, we knows we knows what types we knows with what information we need to read the next argument with var. And also we know where to stop, because if the character we're reading is a null character, then the loop will stop, and then this call will be done via end. For now, we just passed this hello world and 58. According to what we agreed on, the first argument is a string, so we have to pass in 1. And the second argument is an integer, so we have to type in 2. Let's compile this code and see what it does. Like that. Okay, then GCC main, first the main. So here it displayed hello world, then 58. And we can even change, we can even add more parameters, but let's see what will happen if we change the order of these parameters. So according to this logic, we said that the first argument is an integer. So an integer is a 2, not 1. So we must update the order. And here, the second parameter is a string. So each time you change the order, and you have also to update the types, you also have to update the format. This is what we did in here. And next, let's try to add up more things. For example, a character. And next, we're going to add something like a floating point number. And let's add another string, good. And even we can add in spaces and things. This code will still work. So now we have to update the first argument, which we call the format. So the first argument is, according to what we agreed on, the first argument is an integer. So we have to type in the character 2. And the second is a character. We agreed on that character are represented by the character 3. And here we have a decimal number, a floating point number. So we agreed that this is a 4. And this one is a string. So we have to specify 1. And that one is an integer. So we have to specify 2. So let's check again. This is 2 for the first one and 3 for the character. We skipped over the string, so we have to add in the string, which is a 1. So you see that in the format, we agreed on something that each character represents a particular data type, and also it must be in the correct order as in here. Let's run this code and see what happened. I'm going to add a space in here. Maybe let's add another space so that things are going to be more readable. So after this character, there is a string. So let's look at, this is the third character, then a string is a 1. Great. I'm going to run this code, gcc main.c and o main. Let's run this code and see what will happen. This is not, yes. Now let's see that. We have 58, hello world, and see we have been able to display the things in the correct order, because the print function knows how many times it should read using the var arg, and also have all the information needed to understand what is the type of the next character of the next argument. So we just loop over the strings based on the character we encounter. We knows how to read using the var arg, or how to read the next value from the next argument. So this is not a very sophisticated as the printf function, but it gives us an idea on how what is the mechanism behind. So here we agreed on these things, that each of these things represents something in the parameter list. Great. So what else could we do? Let's say if a string is represented by, for example, S, and a number is an integer is represented by I, and a character is represented by C, and a decimal or a floating point number is represented by F. So we're going to update the former. So the first parameter is the former, and the others are the variable numbers of arguments. So here, the first one is an integer. We're going to type in D, and the second one is a string, so S. The third is a character. The fourth is a string, floating point number, a string, and an integer. So the print code, we have to update the print code. So here, if we encounter an integer, it is D. And if we encounter an I, this is a string. If we encounter an S, that means this is with the second argument is a string. And here, this is an integer. This one is a character, and this one is a floating point number. So we can just agree on something and write the function basically according to the way we want to determine how to call the var. Someone asked a question. We're going to get back to that question. So here we have the main.c and the O option for the executable, and let's execute this code. Yes, there is a segmentation fault error. Let's see why. This is probably due to the fact we surely made a mistake on here. Yes. We said that an integer will be a D. So in the code, we have to make sure that D represent an integer, else we might call the var using another type that doesn't match. Let's run this code again. So here it is. We can switch the orders, but when you switch the orders, you also have to make sure to update the format so that things can display correctly. And that's it for the var. Now, this is a very simple function, and I don't think we're going to add much more on that. But for example, let's do a comparison to the printf function and understand how these two things work. So if we were about to use the printf function, we'd have to say %d, %s, %c, %s, %f, %s, %d. So the printf functions knows when we have the %d, that means we're about to read an integer. And if it reads a %s, that means we're about to read a string, and so on. But our function is not that much sophisticated. So if we want this function to understand about the %d, %s, we'd have to change the code and take that in account. So let's compile and see if these two calls print exactly the same thing. I'm going to add a line break here. Okay, so I'm going to call these things. Let's call the execute. So the first things that displays here is the call from our print function, and the second one is the call from our from the printf functions. But the printf function can do some other things much more complicated. For example, we can add things like number. We can add other things. We can mix things up. And still, the printf function will understand that we'll know how to print the string. It will just print it with these. It will print all these, and whenever it encounter something like percent a letter, it will read the next argument, then display it at that position. This is what our print function can't do yet. But it gives us a way of and understand how what are the patterns behind. Let's execute this code and see what it does. So here we have the output from the printf function, and still the printf function can display the strings mixed up with other things. But in our case, we would have to write something, a print function, a bit more sophisticated. So back to the question is, someone asked that how can we print a percent sign? And they also say, can you encapsulate? Let's read the first one. How can we print a percent sign with var, since it is an identifier? And so basically what is happening here is that if you want to make create a function similar to the printf function, you would need to read, this is just a suggestion, you would need to read the string, the format strings, character by character. And every time, so if you read the string, for example, you read n, then you see that it's not a percent sign, you display that character. And next you read another character, you read another character. And when you encounter a percent sign, this is where things get a bit weird. So you read a percent sign, you see that, yeah, this is a percent sign. So the next character will be a format string. So you do an if and you check if it is an S or a D, and if it is an D, you call the var arg. If it is an S, you call the var arg with the string type, and if it is a C, you call the var arg with the int type, and so on. Then you move to the other character, you see that this is a space, then you print the space. You see that the next character is a W, and so on. You print character by character till you encounter a character that is a percent sign. Then you say, okay, this is a percent sign. That means we are facing a format. Then you do an if, then you check if you should display a string or a number. So you call the var arg based on the character following the percent sign. Then you move on once by one. So the printf function is basically printing the strings character by character. And each time you encounter a percent sign, you check if the next character is an S or a valid formal character. Then you call the var arg based on the character following the percent sign. So we can even write the printf function here, but we don't want to give up something like the answer. But still, people can code and propose the solutions, and we can discuss on that. So this is all for the variable arguments and how to create a function that receives a variable number of arguments, and also how to read the arguments using the var arg macro. That is important. You cannot call the var arg with a type that doesn't match with the next argument. So always make sure that we call the var arg function with the correct type. And we also we figured out a mechanism to let the function knows what is the type of the next argument. So if in our case here, this is not a very sophisticated print function, but it does the thing. So I'm going to the next thing will be we're going to look a bit on pointers. Maybe some people need to learn a bit about pointers. Or if there is any question, we can answer.